All right, welcome back for part two of the solving polynomial equations video. Um, our second one here, we see it's a bit of a mess, this, because I can't start factoring it because the one side's not equal to zero, and that's what was so good about this last one is this side was zero, and so when I factored it, I could pick off all of the solutions to the equation or the intercepts to the function. So your first instinct here should be to expand and get everything on one side. So expand and get one side equal to zero, and it doesn't matter which one. When I expand, I get x to the exponent 4. Just multiply through there, multiply through by the minus 2, and then everything goes on one side. Right? And now I can factor this, right? I factor this expression, and I can end up with my solutions. Now, I want to mention there's a couple of different ways to do this. We could think of this as, it's a degree 4, which, scares us a little bit, means we'd have to use the factor theorem twice, but hopefully you're sensing something a little bit strange going on here, right? That this looks familiar. This looks like there's something that we can do, and we can. I'm going to pull out a factor out of the first two, and I get x minus 1. I pull a factor of minus 8 out of the second, and I get x minus 1. And suddenly, I've got a factor by grouping, right? There's a common factor, x minus 1. And look what's left. Does this thing factor? Absolutely it does. It factors as a difference of cubes. Cube root of that, cube root of that. What's left over? The first thing squared, the last thing squared, and the middle term is that times minus 1, which is plus 2x. And this is all equal to 0. Now, what are the solutions? This doesn't factor further. I could check the quadratic equation, but and I will. This doesn't factor. Here I got my solutions are x equals 1 and x equals 2. And from here, when is this thing equal to 0? Try the quadratic equation. X equals negative b plus or minus. And I know some of you have fancy calculators that will do this quickly for you, and you go right ahead and use them. But I'm going to do this long style. This, if they give us solutions, we'd like to have exact solutions. Here, A is 1, B is 2, and C is 4. So I get negative 2 plus or minus the square root of 2 squared minus 4AC all over 2 times 1. And what do I got here? I got negative 2 plus or minus the square root of 4 minus 16. 4 minus 16, negative 12. What does this mean? This is no solutions, right? Not a real number. No solutions here. So what does that tell us? Well, the solution set is just these two things. Graphically, what does it tell us? Well, and by the way, that's it. We're done. We found our two solutions and we're done, but here's a little bonus learning, a little bit of trying to interpret what's going on. What does that mean? If I took this quartic here, I'm going to use a different color, just this is the bonus learning part. If I took this quartic, what that means is there are two solutions at 1 and 2, and that's it. So a quick sketch, we have these two, and we know it starts high and ends high. Where the rest goes, we've got no idea. You know, maybe a y-intercept at 8 there, you know, and then we got, I don't know what else. But what does that mean for the original one? What's going on here? Well, one way to think of this, if I think of this as the left side and this is the right side as two different functions, this is where they cross. They cross at x equals 1 and x equals 2. So, and I'm going to show you that in just a second, as soon as I get rid of my sketch work here. So if I think of y1 as this expression and y2 as this expression, it means that they must cross at x equals 1 and x equals 2. And I'm going to show you that in just a second on the graphing calculator. Let me get that going, and I'll show you in just a second. All right, here's my graphing calculator, and I've noticed I've typed in the left side into the first part and the right side into the second part, and I'm going to graph this. And there they are. There's the quartic that represents the left side. The cubic that represents the right side starts high and ends low. And it appears like there's two crossing points. And we know already, we've solved this algebraically, that the answer is at 1 and 2. But how would I get that on the calculator? Well, and notice I'm just after the x coordinates here. What I would do is I'd use this calc menu, second, trace, and I want to find not the zeros in this one, but the intersection point. So I'm going to try and find the intersection point, and I'm just following the online or the on-screen instructions. This is the first curve. Yeah, dandy, that's the first curve. Is that the second curve? Yeah, that's the second curve. Dandy. So where's the guess? Okay, well, I'm going to have a guess close here. And then it tells me the intersection is at 1 and -2. And again, I'm just interested in the x coordinate that makes this true. And so the x coordinate that makes this true is x equals 1. And I could follow the same process for finding the second x coordinate. So I could, if I wanted to, solve this graphically that way. Notice, in the same thing, I could have graphed this equation to find the x-intercepts, which would have given me the same answers. How does that work? It's because this equation is equivalent to this equation using algebra. And in fact, this equation and this equation are equivalent because they have the same solutions. So one way to solve this equation would be algebraically, but we could have solved it using technology, either the graphing calculator or Desmos or some other graphing technology. All right, what's up? What's up next? That's all the examples, but there is an activity, a review activity that we'll do as soon as you get into class, and then there's some homework there a little bit. And notice, remember to look for shortcuts. The idea of shortcuts here, if I didn't see the shortcut right there, that I would have used the factor theorem, had to use the factor theorem twice, right? I use the factor theorem, find a factor, do long division, it ends up being a cubic. I'd have to use the factor theorem again on the cubic to find a second factor, and it's a long process compared to bing, 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 bing. This was pretty easy. Watch out for shortcuts. All right, that's it.